In lesson 9.5, solving volume problems, we're going to finish up our 7.G.6 in working on volumes of figures made of cubes and prisms. The first one we're going to start on is working with triangles, and I want to show you the relationship between the area and the volume, and that you're only really building on the work that you already know. So if you recall from the area formula, area equals 1/2 base times height, and notice I have a subscript of 1 here, and that applies to this right here. So we have the surface area of a triangle, we have the base that goes across the bottom, and then we have the height going here. So how's the relationship between area and volume then is that we're only adding one more component here. We're going to continue to use the same formula right here to find that area of the surface face over right here. But then we're going to multiply that value by this length, if you will, this height. If we stood this on end, I'd call that the height, and I've subscript that as 2 to represent a second height. So we simply take 1/2 times your base times the height of 1, that gives us our area, and then we multiply that by the height, the subscript 2, and that will give us our total volume. So volume represents whatever the units, so like maybe let's say it's in inches, so it would be cubic inches. So looking here at example 1, they've given us this tent, and we're looking for how many cubic feet are in there, and all our units are in feet. So this is our base right here. This is the 4 is this height right here. So that's H1. And then this height here, this is H2. And then this 5 feet is a piece of information, but that has to do with this leg right here, okay? So it's really not going to have anything to do inside our formula. For area, the first thing we do, we're going to find the base area, which is this front right here. We're going ahead and substitute our numbers in the formula. So 1/2 base times height. So the base is 6 feet. The height is 4 feet. Remember, we're using H1 here. So you go through the multiplication, and the area is going to be 12 square feet. Then we're going to take that, and we're going to substitute it right there. So we're really doing the second calculation, and this H, that's the H2 from what I showed you right over here on this formula. So we do the substitution again. You're going to take that 9 feet, put it in there. 12 times 9 is 108, and it's cubic feet. So when we're dealing with volume, okay, it's whatever your dimension is going to be in cubic, okay? So we say cubic, okay, or to the 3rd power or something like that, whereas area is going to be some value squared. So we need to keep those in mind for our units. So our next shape that we're going to look at is trapezoids, and we have example 2 here. So again, showing you that relationship between area and volume. As you recall from 9.3, area of a trapezoid is 1/2 times the h times base 1 plus base 2. So that's this down here. So you take your values from base 1, base 2, H1, substitute it in place, and do the calculation. Well, we do the same thing for when we're looking for a prism, the volume. You're still going to do all of this calculation, which is the same as here, but we're going to multiply it by this, H2. Notice I put in subscripts again. I have H1, I have H2. So here's my H1 right there. That's still the area that we're looking for. And then here's the H2. So you simply take in those values, put them into the formula, and you go ahead and do the calculation. So going back to the example, we have the values. So this is this one right here, okay? That's my base 2. Here's my height 1 because it's at the face. This is right here from here to here is my height 2. And something that they do a lot in the book, and I think it's a good idea, this is my base 1 here. And they do that because what they want you to understand is congruency. They're saying this 4 feet right here, Okay, that's that line. So congruency means that this line right here is the same value. So that 2 is going to be 4 feet. Okay, so you substitute the values in. That's your base 1. So we have, well, they switched it around. So they say this is base 1 and this is base 2. And the thing for a trapezoid, it does not matter. However you want to be, I'd recommend just be consistent. So 6 plus 4, they've substituted those in. And then you're going to multiply that by 4 because that's the H1 right there. Okay, that's this one, not this H2 yet. And you do the calculation and you get 20 square feet. We now go ahead and they're calling that the base, the capital B, and you've put it in here. But if you recall from substitutions, we have the same formula. So this here is really B. All of this here is what they call, I label this A instead of B by convention because I always use the first letter of the words that I'm talking about. So A for area. So then you go ahead, you do the substitution there, make the calculation 20 times 9. Remember this is H2 here, which is this one, and you get a 180 cubic feet as your answer. Here in example 3, they're using rectangular prisms. And if we go to here, squares, rectangles, and parallelograms all use the same formula. Just remember with a parallelogram, okay, it's slanted, all right, it's like that. But you still have your length and you have your width, okay? So area is length times width, and the volume is length times width times height. So again, the relationship between the two, here's the length and the width, here's the length. I've changed it up a little bit here. I got my width going backwards, and then I have my height going in the vertical, okay? Kind of hard to do that over here on the area side, but it's the same thing, okay? So basically we're taking the length and the width, which is this guy, and we're going to multiply it by the height, and that gives us whatever our cubic relationship is in units. So here what we have to do is we need to break this down into 3 sections, okay? Because we have 3 rectangular prisms, and treat each one of them separately. So we want to deal with, I got a length of 4 for this one, I have a height of 3 for that, and then this goes this way, so that's my width, okay? And then if I take a look, I'll say to myself, well, this kind of looks the same, but let me verify it. So I have my length of 4 going this way. I have, so what happens with this 3 feet and this 3 feet? I'm trying to figure out which way they go. So I think that this 3 feet, it looks to me, goes this way, and this 3 feet goes this way. Or maybe this 3 feet goes this way and this one goes this way. Sometimes these can get a little tricky on how you have to look at it. But if we look at it, if you remember through commutative property of multiplication, if I multiply any numbers in any order, I still get the same answer. So this one I have dimensions of 3, 3, and 4. Here I have 3, 3, and 4. So in essence, they're both the same thing. So I'm going to take my volume formula. Okay, they've switched right here already. Okay, so if I did the volume equals 3 times 4 times 3, so that's the 12 times 3, and that equals 36 cubic feet, okay, and I forgot my units there, so right here. And if I take this and if I multiply it by 2, because I have 2 rectangular prisms, then I'm going to go ahead and get 72 cubic feet for those 2. And then you got to do the same thing for this guy. Okay, so they're telling you got 1 foot there, this one is 1 foot here, and then this length right here is 2 feet. Okay, so I have a 1 times 1 times 2, so 1 times 1 is 1 times 2, that's 2, so that equals 2 cubic feet, and you add those together, this one, okay, they put them down here, and you have 74 cubic feet for this composite figure. If I come down here to the your turn right after that, if I take a look and I really try to figure this out, I can see I have a rectangular prism right here, okay, going back. So I got a rectangle, and then I have a triangle here, a triangular prism. So what I want to do is I want to break those up. I want to find the volume of a rectangle plus the volume of a triangle, and then the volume of a triangular prism, and treat those separately. So I have dimensions here. This is, I want to call this my height, and then this one I have, this is my H2, and this I have, this one I'm going to put as my width, and this one is going to be my length. Okay, so my length going across this way, my width this way, and my height going this way. And then of course I have my triangle. Notice here though, they give us a separate dimension here, so that's 9 inches. Sorry about covering that up. So that's 9 inches, but this, going this way is 30 inches because this line is congruent to up here. Okay, and then you have this 13 inches for going there in that vertical. So substitute those into your equations and go ahead and do the calculation. You got to add those two together, and that will be your volume for both of those together. In the guided practice, what I would do is I wouldn't necessarily worry about this, okay? And the way they have it set up, it is something to help you out. But if you look at your formulas that we talked about, we have the area and the volume formulas for square, rectangle, parallelogram. For a triangle, again, the area and the volumes that we talked about. And then the last one is the trapezoid, the area and the volume. I would just go ahead and take those formulas, and I would just, okay, which one are you going to use here? Well, the triangular prism. Which one here? This one here is a composite figure, so you actually have two things that you have to work with. You have a triangular prism and you have a rectangular prism, similar to the your turn that you'd worked on before. So if you got any questions, let me know, and I hope this all helps you out. Have a good day. Bye.